Hello, hi, welcome to another video tutorial for Etabs 2015. In previous class, we have seen that how to do response spectrum using IS codes of Indian Standard 1893. So today we will talk about time history analysis. So how we can do time history analysis according to IS codes and what are the benefits and what are the results and how we can take out the graphs and which earthquake load should we take while doing this and why should we do time history analysis. All these things we are going to know in this tutorial. So we will use the previous building what we have did for response spectrum analysis. So please watch our previous tutorial if you don't know how to create a model. So the model of the building is ready with us. So if you don't know how to create this model, please go to our previous videos. So let's start this tutorial. So what is time history analysis and why should we do this? As we know, in response spectrum analysis, we know that we get to know about the responses of the building at different modal case. So at different mode shapes of the building, uh, we get the different periods and the frequencies of the responses and the response spectrum curve from the response spectrum. But for a particular area and particular earthquake data, and for a particular time period, we cannot find the response spectrum according to our required data. So if we want to analyze our building according to our data, we should consider this. So what is time history analysis first? In time history analysis, the structural response is computed at a number of subsequent time instant. Interval of time whatever is required means uh, per second or per nanoseconds we can consider the time, and according to that time what is the deflection and what is the response of the building we can find according to the lateral load applied to the building. So whatever lateral load we are applying, according to that load, the time according to the our required time, we can find the at particular time what is the response of the building. So this is the benefit of time history doing. So in other words, we can say time histories of a structural response at a given, okay, to a given input are obtained and a result is obtained on that given input. Okay, in response spectrum analysis the time evolution of response cannot be computed. So the time evolution we cannot do in response spectrum, but in time history analysis we can do it. So this is the benefit of it. So how to start with time history analysis? So first we should know what are the methods in time history analysis. So if you go to website of CSI for Etabs, you can find the Etabs time history analysis manual. In this manual you can find the different types of time function, what can be assumed, and what are the different forms of time history analysis we can do, and which is the best form we can select for our required building or required model or structure. So this time function, what is a time function? Time function is divided into two types, that is linear cases and non-linear cases. For the linear cases, the time function will be starting from 0, and therefore corresponding the time function must also start from 0. So in linear cases the curve of the time function starts from 0. In non-linear cases it may start from 0 or it can continue from its previous case. So these are the two forms. Mostly we consider the time function in non-linear cases for most of the earthquake load, because the earthquake has started at a different point and maybe the our building is located at a further distance from the epicenter. So that is the earthquake case. If epicenter is far away, or how much is the distance, so it and the function is already started. But when it reached our building, so that time the curve of the earthquake is already started. So we can find that at different time period and different lateral displacements of the ground, we can find the response of the building according to the non-linear cases. So we will study about the non-linear cases. In non-linear cases, again we can do two types of analysis for time history functions, that is the fast nonlinear analysis and the direct integration time history analysis. These two types we can do, and these are the other, that is progressive collapse for studying the building, collapse study of the building, and for periodic time history analysis this is another case. So we will leave these cases for later classes. For now we will know about the fast non-linear time history analysis. Why we are doing fast non-linear time history analysis means these are very important. And fast nonlinear time history analysis is a modal analysis method useful for the static or dynamic evaluation of linear or nonlinear structural systems. Because of its computationally efficient formulation, FNA is well suited for time history analysis. And when we compare FNA with the direct integration time history analysis, FNA is much better and fast, reliable. See, the nonlinear model time history analysis, also known as the fast nonlinear analysis, is generally more accurate and efficient than the direct integration time history analysis. Actually, the direct integration time history analysis does the integration one by one step, and it takes lots of time. But when we see the fast nonlinear analysis, it will do its by own, and it will give more accurate values for the model cases. So for time steps, equal time steps, so the time in direct integration is accurately characterized when if you want smaller time steps. So very smaller time steps if you want, then you should go for direct integration. And if you don't want, uh, for uh, you want to complete it fast, then you should go with fast nonlinear analysis. So now we will start with the FNA case of time history analysis, and for the first case we will go with the earthquake of El Centro function. So for doing the time history analysis on the previous structure what we have already made ready to use in our previous tutorial, you can see. So that structure we will unlock it now, so that we can make the changes to the structure. So we will go to define, and we will define a function of time history now. So in this, two time history functions are already mentioned in the definition. We will delete these function, and we will assign or assume a new function, that is from the file, that is from file you select and you click on add new function. So you keep the function name as time history function. Select a file from the for the time history function. If you have a file of your own earthquake data, you can get it on online website for different areas. And for that large scale earthquake, you can select the data and you can analyze your model on that. But we have the predefined functions in the program, and we can browse it from here. Then after that, you go where you have installed your program. Go to C programming, program files, where we have installed our Etabs 2015. Go to computer and structures there in the program files. In that Etabs 2015, in this you can find time history functions here. You go to that and you can select any of the earthquakes here. So the most dangerous and most disastrous earthquake was El Centro. Take this one as our function. So select El Centro and press open. So this will show the graph of El Centro, and you can see the time and function values change here. You can check you can check the values for equal intervals of your required seconds, so zero point 0.1 seconds or 0.01 second or 0.02 second, whatever is given. And the header lines to skip, it is given 2, it is given number of lines per points per line, it is given as 8. So it is already set. The format type, you can select it as fixed format or free format. So we are taking it as free format, as whatever the values given in the file. So we are taking this El Centro case. Press OK. Now we will define the load cases for the we'll give the name of the load case for x direction as THX. We will go with the time history function and we will select it as nonlinear FNA. The load case type is time history and the time history type is your nonlinear FNA we are doing in this one. The mass source will be remain same and the zero initial condition has been set up. Now we can add a load applied in the direction of acceleration u1 direction for x direction, and the function you should select here El Centro function, and for the time being you keep the scale factor as 1. Let the model load case be model only, and the number of output time steps is 100. The time step size is 0.1 second, or you can change it to 200 here. The more the steps will be, the more accurate results we can find out from the. So the modal damping of the structure is 0.05 by default. The nonlinear parameters you can check here, it is set to default values. Press OK. Similarly, you create a file, add a copy of this and keep this name as THY for the Y direction and change this direction to U2, and the function is El Centro itself, and all the remaining things being same because we have copied the first and we have just changed the direction of THX to THY for U2. Just we are changing the U2 and the name here and we press OK. So two load cases has been added, that is THX and THY, according to the El Centro earthquake data function. Now press OK. So the function has been applied And now we can go for analysis. Before analysis, you should set the load cases to be run. We are just not running this time the wind and the response spectrum curves. We are just running the dead live earthquake X, earthquake Y, and the THX and THY this time. Press on run now. The analysis will take some time. So after the analysis is complete, we can see the deformed shape of the building on the right hand side, and the joint displacement has been shown on this figure. But this is according to the load case we have taken for THX and THY. We have taken the scale factor as 1, but we have to change the scale factor to the required the scale new factor of the building, whatever according to the base reaction comparison. So as we did in the response spectrum analysis, in this also we have to consider according to the IS code 1893 for response spectrum and time history analysis. The base reactions of the time history should be equal or should be 75 to 100% of the base reactions of the structure. So to see the base reactions of the structure, go to display and the show tables. Click on tick to the tables and press OK. The tables will appear at bottom. So the tables have been appeared at the bottom. Now select here the base reactions. In this you can see that the EQX value is 954.1642 for Fx, that is base reaction in the X direction, and the base reaction in the Y direction is same because we have taken a symmetrical building. It will be different for different building, and in this you can see the TH max value doesn't match with the EQX value. So these values should be 75% to 100% same according to the zonal area of the building. So according to the new scale factor, what we should consider is the scale factor. The new scale factor would be Ig by R into 0.85 if we are taking the 85% of the base reactions, then 0.85 into the static base reaction what we have obtained divided by the response spectrum or the time history base shear. So the base shear we should divide with the static to the time history now. So here we have for EQX is 954.164 that should be divided by the THX value, that is 13.8, equals, this is 69.14. This value should be multiplied with 0.85. the value goes to 58.77. This should be multiplied by Ig by R, and we have already seen that for this building Ig by R we have taken as 1. So 1 into this value is this value itself, that is 58.77. So we will change the structural value of time history functions, the load cases. So first unlock the model, go to define load cases, go to THX and press on modify showcase. Here change the scale factor to 58.77. Press OK. Similarly, for the THY it is same because we have taken the symmetrical. So we will modify this to the same value, 58.77. Press OK and then again press OK. Now again analyze the structure based on the same load cases. Run now. This time we will get the responses for the time history and the earthquake. Base reactions will be same, or the 80% variation. So after the analysis is complete, we will display the tables again. We will go to the base reactions, and now you can see it is 85% of the EQX we have modified as per the scale factor. So this is the new value of base reactions according to this structure. Now what we should consider in this is, after time history analysis we should check for the results here, that is MPMR values, that is modal participation mass ratios values, and you can check the sum of the modes up to the final mode, that is 15th mode. The sum of UX and UY should be equal to 1. We can also check the frequencies and of the modes. For different period, what is the frequency and what are the eigenvalues. By taking these eigenvalues, we can find the mode shapes and the responses of the structure. We can check the story acceleration here. And it will show the maximum story acceleration and the minimum story acceleration of the THX case and the THY case separately for different stories, story 1, 2, 3, 4, 5. And the response spectrum curve we can see from here. Go to the display and response spectrum curves. For THX in the X direction, we can see the maximum response here. It is at 0.9 seconds, that is 3300 value of pseudo-spectral acceleration for the minimum damping, that is 0 damping, and for the maximum damping it is very less. You can see if we take the damping factor as 0.1. By this we conclude this tutorial. For more question and answer, you can comment below, and For the links you can go to the description, and to know more about the Etabs tutorials, go to the playlist at the right, and for the previous video go to the link on the left. And please subscribe and share this video. Goodbye.